So Unit 2, required skills, we covered 3 sections, 1.2, 1.4, and 2.2. So those are the sections from the book. For every section, you have a notes packet, and on the top of every time I give you notes, it says like learning goals or objectives or whatever on the top. Nobody ever reads those, but they're there. And so this list that I made is literally, I took those learning objectives and made them bullet points. So going forward, when we have a test, that's a good thing to do, is kind of take your notes packets, look at the learning goals, and say, okay, this first goal, do I know how to do that? The second goal, do I know how to do that? Okay, so that's what this is. So section 1.2, just make sure you understand like function notation. If I say, you know, f of 2 on this graph, you know, there's a picture of a graph, can you look at where x is 2 and tell me what the y is? All right, that's basically what that means. Symmetry, that's y-axis symmetry, x-axis symmetry, or origin. And remember, testing that algebraically meant either plugging in opposite of x when you're testing for y-axis symmetry, opposite of y when you're testing x-axis symmetry, and opposite of both for origin. Remember that? Okay. And then once you have that information, you can classify the function as odd, even, or neither. Remember, even is y-axis symmetry. Odd is origin symmetry, and then there's neither, right? And remember, we said x-axis symmetry isn't, you can't use that to like determine whether a function is odd, even, etc., because x-axis symmetry is literally not a function, right? If it's symmetrical over the x-axis, that means it's actually not a function. The vertical line test wouldn't work. Okay, find domains and ranges. Interval notation, make sure you know where to use brackets and where to use parentheses. Bracket means including that point. Parentheses means not necessarily including that point. All right, y-intercepts. All of these things you should kind of be able to tell from the graph and algebraically. So y-intercepts, remember, plug in 0 for x. X-axis symmetry is basically plugging in 0 for y, but this involves usually factoring, right? Or looking at a graph and seeing where it crosses the x-axis. I'm going to post this document, so you'll be able to refer to it, but if you want to jot down a few things here. Okay, so determine 1.4, determine intervals for increasing, decreasing, and constant. Remember this one, always use parentheses, no brackets for this one. Because you're showing over the interval whether it's increasing or decreasing. It's really not talking about at the points. All right, and then maximum and minimum. There's the absolute max and the relative max. There's the absolute min and the relative min. All of those things you should be able to tell from the graph, just like estimate from a pictured graph, or plugging into your calculator using that second calc, right, function, and then finding the minimum or the maximum. 2.2 was the last one that we did. End behavior. Remember, we're going to write it using limit as x approaches negative infinity, etc., like that. Leading term tests, that just refers to telling whether it's positive or negative, and if the degree is even or odd. All right, and then finding zeros, again, that can be called intercept solutions, roots, etc. That's factoring and being able to solve that algebraically. Determine the number of turning points. Remember, that's just one less than the degree. Degree minus 1. And then the multiplicity, of a 0, that's how many times that factor occurs, and that determines whether it bounces or crosses, touches or crosses the x-axis. And then just generally being able to graph. So you're kind of pulling all this together to be able to accurately graph a function. Okay? Yep. So there will be a non-calculator section and a calculator section again. So don't forget to look at the word problems too. Optimization word problems. So maximizing volume or area or profit or whatever.